Okay, good morning or good afternoon, whichever period you might have. Today we are going to move on to the third section of your geometry book for chapter 10. This one is going to be spending a little bit more time with arcs that we introduced last section, but it's going to add in how those and chords. Remember, a chord is a line segment inside of a circle that touches the edges of that circle in two places. So like this line segment up here in this particular circle, FG, that is a chord because it has its endpoints both on the edge of that circle, both on that circle. Okay, so that's what we're going to spend some time talking about today, how chords and arcs are related. Okay, so the first theorem in this section is about chord congruency of minor arcs, and pretty straightforward. Nothing that I think is going to really wow anyone here. If we're in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So let's look at this. Think about this from one perspective. You know, if we have the chords being congruent in the last section, that meant that the central angles are congruent, right? The chords were congruent and the central angles were congruent if they were in the same circle. And that would mean then, since these little pieces here that make up the central angle are all radii, that we have these two triangles that are side angle side congruent. Okay, so we have side angle side for these two different triangles. So they are congruent. If they are congruent, then all of their parts are congruent, and that is why FG and JH are congruent as well, those two line segments. So their chords are congruent if their arcs are congruent. Also, if the chords are congruent, then their arcs are congruent. It goes both ways. Okay, remember that's what that if and only if means, right? It means that that means we can go either one way in that theorem, or we can do it in the opposite way. Okay, so either we can have two minor arcs being congruent, therefore our chords are congruent, or we can have our chords are congruent, therefore our two minor arcs are congruent. It doesn't matter which way we go. All right. So the second theorem that you have in this section, this is about chords which are perpendicular to something. So in this case, if we have a diameter or a radius that is perpendicular to a chord, so you can see right here, this diameter AB runs perpendicular to the chord XY, right? If that's true, then that diameter or radius bisects the chord. That means it's going to divide this chord up into two equal parts, meaning that XZ is going to be congruent to the line segment ZY. Okay, so if we have a diameter or a radius that hits a chord and it makes it at a perpendicular angle, right, then makes it a 90-degree angle, then what we're going to say is that those two pieces of the chord that it divides into are both congruent to each other. Alright, next, if we have a perpendicular bisector of a chord, that perpendicular bisector of a chord is, in fact, a diameter. So if I have something that runs perpendicular, this is just going in the other direction, kind of. If we have a perpendicular bisector of a chord, then that segment is a radius or a diameter. So it's just the same thing going in the opposite direction. Alright, and the last piece of information we're going to need for this particular chapter is if we have two chords Okay, if we have the same circle or we have congruent circles, we have these two chords, they are going to be congruent if and only if they are equidistant from the center. That means if they are the same distance away, basically if, in this case, LX is congruent to LY, if that is true, okay, then that's going to mean that FG is congruent to JH. And this, because we're using that if and only if statement, that means that this can also work in the other direction. Meaning I could say if I have those two chords being congruent, then I will have, then those two chords are going to be equidistant from the center. Okay? Great. So that's all the information. It's not a ton of stuff to kind of hold on to. I hope you wrote it all down, and you can. Now we're just going to need to practice it all to make sure we can get used to it. Now at this point in time in a chapter, we've gone through 3 sections. It's really important that you are taking the time to review the previous theorems that you've been doing. Okay, so we've hit enough theorems and definitions now that you should be spending time going back through these things. If you're not spending the time to go through them, then you're not going to be spending the time to remember them, and then when it gets to a test or a quiz or something happens later on in another chapter or section, or maybe even if you want to talk about beyond this course, a standardized test like the ACT, then if you haven't spent that time to kind of really solidify them into your brain, you are not going to be able to recall them when you need them. Okay, so I really think it's especially important, especially in a course like this in geometry, where it's a whole lot of words and a whole lot of vocabulary, right? And it's all based around these theorems and postulates and axioms and definitions, that you spend time going through those things. Okay, so that means you either need to be making flashcards, or you need to be going back through your notes, or you need to be spending some time not just working the problems, but you also need to be spending time looking at the theorems and definitions. Okay, I cannot stress that enough. If you are not doing that, you are doing yourself a disservice. Okay. While I'm talking about doing yourself a disservice, I would just like to say thank you to the people who have signed up so far for Khan Academy. I realize right now this is Monday afternoon, okay, and there's some people who might be signing up tonight or this afternoon, late this afternoon. But as of right now, over half of you have not signed up for Khan Academy, and this is going to eventually affect your grade. So I recommend, highly recommend, you do so, and do so soon, before you get nice, juicy zeros showing up into your eye now. Okay? So I've put the code up. It's on the back of the classroom on the board. You can see it right here. Look, there's the code. YGNXFN inside of this video. I put it up in the last video. This code is available to you, alright, to see. It's not like I'm hiding it. Alright, it's there. Also, I don't know if you've spent a lot of time on the school website, but if you go to the school's website, you can type in www.lamphighschool.com, and you come down here to where it says school staff. You'll load up this page with all the people's names, and if you find my name, hi, that's me, Mr. Daniel, and you click on it, and you go to links, okay, under my thing, if you go to links, then what you're going to come across is my YouTube channel. I have linked my YouTube channel to my school webpage, and when I'm done with this video, it will also be there up on this YouTube channel. Okay, so I'm hoping you can use that to have access to this information should you not be there one day, should you be absent or something, or should you forget something, would like to look back at it again. This information should be here for you to be able to come across. Okay, so I'm hoping that you will use this information to your advantage, please. Okay, that's why I'm doing it. I'm not doing it for myself. All right, so now that we've gotten through all of that fun business, let's talk about some examples. All right, because why not? Okay, this one, when I copied it over, came out a little blurry, but it's on your page, on your notes. Alright, we have this embroidery hoop, and in this embroidery hoop we have the line segment, or the chord, I guess I could say, AB being congruent to the chord CD. Alright, and then they told me that the measure of the arc AB is 60 degrees. So they've given me that these two line segments, these two chords, are congruent. And we learned that if the chords are congruent, then the measure of their arcs is also congruent. So that means the measure of CD's arc must also equal 60 degrees. I mean, amazing, right? Right. So now that we have that, okay, that was a nice, simple beginning example. All right, let's go talk about example 2. In example 2, this one came out a little bit cleaner. If we have these two circles, circle J and circle K, and they are congruent circles, notice that they gave us that information here, very important. And then they're telling us that the line segment, the arc MN is congruent to the arc PQ. I would like to find the measurement of line segment or chord PQ. Remember, just like we used in the last one, we know if their arcs are congruent, then that means their chords are also congruent, or the other way around. So in this case, I know since these two arcs are congruent, that means that also M in the line segment is going to be congruent to PQ. And if that's the case, then that means those two values that they have listed for these two things can be set equal to each other. So that's exactly what I'm going to do. I'm going to say 2x plus 1 is equal to 3x minus 7, because I know that these two values must be the same. I'm going to subtract 2x from both sides. I'm going to add 7 to both sides. And when I do that, I get 8 is equal to x. Unfortunately, they did not ask me for x. I need to always kind of keep that in mind. What on earth did they want me to find in this problem? They wanted me to find the measurement of PQ. So to find the measurement of PQ, I'm going to put that value for x in for x. So PQ is equal to 3 times x, or 8 in our case, minus 7, which is 24, minus 7, which is 17. So PQ is 17. Alright, so I hope this feels okay. Again, we're using the same theorem we used in the first example, that when we have congruent circles, if those congruent circles have congruent arcs, then their chords must be congruent. Alright, in the previous example, we used the fact that their arcs were congruent, that their chords were congruent to prove that their arcs were congruent, to get information about that. This time we're doing it the other way. The arcs were congruent, therefore the chords were. Alright, so hopefully that kind of all feels like it's all a part of the same realm of existence, okay? Hopefully that's not some sort of like mind-boggling thing and people are falling out of their chairs right now, okay? Alright, next. We want to talk about the arc of PQR. That's kind of an interesting choice. You know, they didn't have to say PQR, right? They could have just said PR, because that's just a minor arc. And they're giving us that value. They want us to find the measurement of the arc P to Q. Okay, so I just need to find the measurement of that little arc when I know the big arc. So I know the big arc here is 98, and the really important thing here wasn't talked about in this statement. The really important thing is talked about over here on the drawing itself, and that is that we have this little segment here, SQ, which happens to be a radius, running perpendicular to this chord PR. And we learned just a little while ago that if that happens, right, if we go back to our notes, okay, we'll see that if we have something where it runs perpendicular, then it bisects the chord and it bisects the arc. Okay, so if we have our diameter or radius that is perpendicular to the chord, then it bisects both the chord and the arc. So that means that both PT and TR are the same. And it also means that chords PQ and QR are the same. Okay, so I know that PQR is the whole thing across. Okay, the measurement of PQR. Well, that must equal the measurement, right, of PQ plus the measurement of arc QR. And they happen to be the same. So it's kind of like I could replace QR with PQ. I'm doing this in a very like geometrical proof sort of way, just to kind of remind you of what that's like. Okay, I realize some of you probably already had the answer the moment you realized that those two arcs were the same. But you know what? We're going to do it the long way. So this is 98 right here. Those two things are the same, so really that's 2 PQs is going to be equal to 98. Or in our case, PQ is equal to what happens when we divide 98 by 2, which is 49. Okay, so that's kind of a long way to go about it. You know, we know it divides it into 2 equal parts. That means those 2 parts must be the same. If they're the same, then I could just divide that whole thing in half to get the real value. Okay. I also want to talk about something else, something that is not asked here in example 3, but I'm going to ask it to be to kind of add a little bit of extra information here. Okay, they gave me on the picture the measurement of TR. Could you find the measurement of the line segment PT? Okay, so I want you to think about that. All right, by show of hands, how many think you can actually find the measurement of PT? All right, surprising. And what's that measurement? That's right, it's 6. That's correct. Yeah, it's the same thing. Okay, so if I asked you for the measurement of all across PR, yep, that would also be 12. Okay, hope that feels good. All right, felt good for me. All right, let's go on to example 4. Oh, wow, look, it's a stained glass window. How beautiful. All right, they have a diameter GH on this stained glass window. They tell us that value is 30 inches. And we have a chord, KM, okay, which this chord right here, KM, that is 22 inches. All right, remember GH, that's this right here. All right, so that's 30. They want me to see if I can find the distance from J, okay. Let's see if I can do that with something that's easier to see. They want to find the distance from J to L, okay. All right, so let's see if we can figure this out. This is going to be a little multi-step process here. GH is a diameter. If GH is a diameter, let's just think real fast about life, and let's see if we can think about what might be true, okay, about the radius of this circle. Look, I'm just going to draw just a randomly placed radius, okay, from J to K. How long is that going to be? If the whole thing is 30, then yep, you're right. That would be 15, okay? So 15. Well, if that's 15, okay, then that's not quite getting me to the answer for JL. I mean, I see that they drew this triangle as a right triangle. That means that's a perpendicular angle. God, it would be nice if I knew what happens when a diameter or a radius hits a chord at a right angle. Oh yeah, like that theorem we just had that said it bisected the chord. Yeah, that would be useful for me. So that would mean that this KL and LM must be the same. And since the whole thing is 22, that must mean that I know each little piece is 11. Ah, Well, now I know two sides of a right triangle, and the side that I'd like to find, JL, happens to be the third side of that right triangle. Man, after all those chapters on triangles, there's like 20,000 chapters on triangles you did, I bet you somebody could tell me of some sort of famous theorem that starts with a P that has to do with a right triangle, right? Yeah, that's the Pythagorean theorem. So we're going to say that this JL value, I'm going to call that X, okay, because I don't want to write JL a million times. All right, X squared plus the other short side, 11 squared, which is 121, needs to be equal to 15 squared, which is 225. That needs to be true. I'm fairly confident in that. Are y'all fairly confident in that? Good. All right, so we're going to subtract 121, and when we do that, we get x squared is equal to 104, and then we're going to square root that sucker, and we'd have plus or minus, but x can't be negative. Makes no sense for a line segment to have a negative measurement, right? So it's going to be the square root of 104, okay? And I would just leave it like that, all right? Because 104 is like, what, 57 times 2, so I'm not really going to try to think about how I might be able to simplify that. Okay? I'm just going to let it ride. Okay, feels good. I'm liking this. All right? Oh, 104, a square root of 104 what? Square root of 104 inches. Okay. Do we need to add that measurement in? All right, example 5. In this example, I have that this big chord WX happens to be the same as this chord XY. They both have a measurement of 22. I want to find not anything to do with those chords. I actually want to find something to do with the distance to the chord WX from the center A. Alright, so I just want to find that measurement. Well, it turns out if two chords have the same measurement, right, and they're both reached to by some perpendicular, then those two measurements, right, and that according to that last little theorem here, right, if the two chords are congruent if and only if they are equidistant from the center, right? And to find the distance from the center, we're going to take a perpendicular line to that. That's how we get to something the fastest. Okay, we go to it where it's going to intersect at a right angle. So that means this measurement AB and this measurement AC must be the same. And they've given me those values in terms of x. One of them was 5x. The other one was 3x plus 4. And remember, because these things have congruent chords, right, then that means those perpendicular lines that go to them from the center must also be the same. Okay, for some reason I wrote B instead of 4 here, so let's just take care of that real quick. Alright, so that means I'm going to subtract 3x from both sides. That gives me 2x is equal to 4, or x is equal to 2. And now that I know that, I should be able to find the length AB. AB is 5 times x. 5 times 2 happens to be 10. Alright, so that one's not bad when you realize what it is asking of you, okay? So you got to kind of slow down sometimes and think about the theorems and definitions that we know. That's why I was saying at the beginning of this section why it's so important for you to go back and look through these things after class is over. When you're in time outside of this class, you should be spending time looking at it, okay? If you don't do that, it will not stick into your brain. Alright, next one. I have circle H. PQ is 3x minus 4, so that's that distance right there. And RS is 14. I want to find what X is. Huh, well, that's interesting. They gave me some information about two different chords, but they didn't really say very much else in that little statement. So let me look at the picture and see if I can get any more information. On the picture, I see that there is a little line coming from H out to T that is perpendicular, and a little line coming out from H to U that is perpendicular. Those are the distance from the center to the chord, and on both chords. And those two numbers that they put above them, they say they're both equal to 8. So what that means to me is that these two things are equidistant from the center, right? And as we just said, if we have things that are equidistant from the center, right, then their chords are congruent. Okay? So we can go both ways. So, if their chords are congruent, that means their measurements must be equal. That means 3x minus 4 must be equal to 14. If I add 4 to the other side, I'll get 3x is equal to 18. If I divide by 3, I'll get x is equal to 6. And hallelujah, I have done it. I have found the value for x. That's actually what they wanted me to find this time, right? Always be careful. Make sure that's what they want you to find, right? Sometimes we find x and we get very excited about it, and then that's not what they were asking us for. It was just a step along the way. Okay, so hopefully by now you know a few things. You know how to handle chords and arcs. You know about the parts of a circle, and you know about the measurements of circles, the 3 things we talked about in this chapter, right? Also, hopefully you have been reminded that if you have not already, you will sign up for Khan Academy. Okay, I cannot stress this enough. Sign up for it. Okay, and then also, hopefully you've kind of been given a good way to be able to find this video on YouTube, so that you can access it when you need it. Okay, and hopefully this is going to be going well. Either I will assign some stuff for you on Khan Academy, or I will give you a sheet of paper to work some of these problems out so we can see how you're doing. And I'll see you next time.